Hey everybody, welcome back to Video Game doing series on the MiSTer FPGA DE10 Nano project. More specifically, in this instance, some of the updates Jotego has been giving us, not only in regards to Capcom CPS III, but how him and his team are going to be getting there. Because I would say the number one hot button topic of summer 2025 on the MiSTer FPGA side of things is a Capcom CPS III core. It is still one of the most requested arcade cores out there, and because Jotego has CPS and CPS II already buttoned up and released, it is the last and final boss to get the entire run going. And we're going to take a look at golfing greats here on MAME, not on MiSTer FPGA, because it doesn't technically exist yet, but I'm going to explain to you how these developments are going to lead to a Capcom CPS III core in the future. And before you ask me when that's going to happen, I have no idea. Next month, next year, 18 months from now, there really isn't any time frame. Before we get too much further involved though, do me a huge favor down below, hit like and subscribe and ring that notification bell, definitely helps us out. And if you feel so inclined and want to support the channel, we got a Patreon link down below as well. But basically, the stepping stones to get to Capcom CPS III, iteratively at least, are going to be going through some Konami arcade boards. The Jotego already has a lot of the hardware buttoned up for FPGA in. Now we are taking a look at MAME footage here, and this is golfing greats, and it uses a special Konami in-house developed chip that gives you a pseudo 3D look. Now this is not as advanced as Run and Gun, another game I'll be talking about in the run up to Capcom CPS III, but this was pretty impressive for its time and era. It kind of has a Mode 7 style effect from Super Nintendo, except in an arcade format. But this game definitely doesn't emulate very well, but it is something that Jotego is working on to bring over to Analog Pocket MiSTer FPGA, and it does aid in the development of Capcom CPS III, because when you get to these levels, as far as arcade cores are concerned, so many games work and inform for other games the type of code you're going to want to write. Now Jotego's also talking about Konami's Run and Gun, which uses a more advanced version of that custom chip, and this gets about as close to 3D as you could possibly get in a game that is using nothing but 2D assets and can't actually render any polygons on screen. Because if you take a look at the court, the audience in the background, and all of the players in scaling, it's about as close to a 3D environment as you could get without actually having any 3D on board. And that is because in part this is going to use a frame buffer. What a frame buffer is basically just a storage area to actually hold the next frame or couple frames that are going to be drawn to the screen. And that is something that the Capcom CPS III has to have if it's actually going to display any images on screen. So you have something like golfing greats with that pseudo 3D chip that also needs to be worked on and advanced for Run and Gun, which has that frame buffer, which is going to be useful for Capcom CPS III. So you can kind of see the stepping stones from one game to the next game, golfing greats to Run and Gun, and how that leads into Capcom CPS III. Now granted, they aren't using the same silicon, but a lot of this is more conceptual than it actually is the silicon base, because the CPU on something like golfing greats or Run and Gun is not going to be the same Hitachi SH2 that's in the Capcom CPS III, but of course that is in the Saturn core that we do have. And this is going so far that Jotego's even actually adding some commits to MAME, basically to try to solve some of the audio issues that are in golfing greats, because when they basically go and reverse engineer this along with Vertex schematics, they can find issues in the MAME implementation that are not only going to aid software emulation but also FPGA. This is what it currently sounds like. It's not quite right, and I'll be right back to explain more.
Good.
Now, while there's nothing about that audio that's unpleasant to the ear, you can obviously tell it's not correct. What Jotego found while working on the FPGA core from Vertex schematics is the interrupts were not correct in MAME. The interrupt is going to be on the Zilog Z80 and not the Motorola 68000. If you're wondering what an interrupt is, it's basically just a way to stop somewhere in code and do something else. I'm not going to get any more technical than that because it really doesn't make that much of a difference. But into the development of the FPGA core for golfing greats, which leads to Run and Gun, which leads to Capcom CPS III, there were some issues found that will even help button up MAME emulation. And this is how a lot of the reverse engineering happens. You get schematics and they basically have all the different chips and all of the signals that are going to come off each leg and what they do, whether it's an interrupt, whether it's some sort of RAM access tied high or low, or maybe even a ground pin or a voltage pin. This is what you go through when you're not only trying to reverse engineer the boards for FPGA development, it's also what you use when you're just trying to repair arcade boards, because if I want to know why I'm not getting access to RAM, I can check whether or not it's moving high or low, or it's stuck in between if I have the schematic and actually check things. And as far as why I'm continually being out of bounds in Golfing Greats and MAME, it just seems to be that the emulation isn't buttoned up yet because it's basically not doing anything and not working the way I would expect it to. But again, a lot of the FPGA development can and has improved MAME, and a lot of the MAME documentation has helped FPGA core developers actually get these things out. So if you take a look at CPS3, what we know here is it needs to have that frame buffer so it can actually draw all of the images onto the screen. And if you're wondering, no, not every single console on MiSTer FPGA, not every single arcade board is going to have a frame buffer, not in the way that we're talking about with the Capcom CPS III, but these things are absolutely crucial to the operation of the system. Now again, on the MiSTer FPGA side of things, the Hitachi SH2 CPU is basically 100% buttoned up on SRG 320's side for the Sega Saturn and Sega Titan video core. So a lot of the developments on MiSTer FPGA in general can and will be used to aid in the development of other cores. That's why you see something like Capcom CPS III suddenly being talked about a lot from Jotego, because some of the work, at least foundationally, has already been done, and because MiSTer FPGA is an open source project, everything is used by everybody to aid in the development. So that's going to be really exciting on the Capcom CPS III side of things, knowing that at least that portion is kind of actually done and dusted. But of course, Capcom CPS III has a lot of other custom silicon on board as well, and that all needs to be dealt with, including that frame buffer. But you can reuse code from one core to the other so long as you can actually tie it all together. And that's why you're going to see something like Run and Gun come to MiSTer FPGA first. It solves the issue with the frame buffer code that it seems like Jotego's going to need when he's actually making that Capcom CPS III core. So you go from Golfing Greats to Run and Gun to Capcom CPS III, even though the boards are not made by the same manufacturers and they really don't share any hardware in common. They share a technological concept in common, and that is going to be useful when it comes down to the framework of getting these things to run. Now again, I can't stress enough, don't get too excited. I have no idea on the dates for these things. It would be really fun if we were playing Capcom CPS III even in a beta core by the end of the year, but it could be something like summer 2026 that we're talking about here. These things take a very long time, and the Capcom CPS III is a very advanced piece of hardware for its time and era, and we'll be pushing it to MiSTer FPGA in a lot of different interesting directions. And Jotego even mentioned fixing up some of the issues on the analog pocket core for Outrun, which is also going to aid in that frame buffer. It's one of those things, so many of these things are just basically domino effect. You knock one down or fix one bug, and suddenly you have useful code and useful concept all the way down the line to help develop the core that you're currently working on. And considering Jotego has made so many different cores for MiSTer FPGA and Analog Pocket, you can see why going back in and fixing up a small bug that only affects a couple analog pockets could end up helping the Capcom CPS III core development. These things are also intrinsically tied together, and we do have frame buffers on MiSTer FPGA as well. VDP1 on the Sega Saturn actually has a dual frame buffer, so we know this is something that can run in FPGA. We know it's something we've had before, and we know it's something that we can deal with again in the future. But these things are crucially important because without the frame buffers, you're not getting images drawn to screen. Think about the old days of the internet where you're waiting for a video to buffer enough so you can actually start the playthrough and not have to pause. That's a buffer in the same way that a frame buffer is, maybe not in the technical execution, but in the concept of having to get that data ready to display and having to do it ahead of time so you don't end up in a situation where you either have a blank screen on something like an arcade core, or you end up pausing the video and having to wait for it to load up again on your PC. So that's why Jotego has been talking a lot about these Konami boards, Golfing Greats, and Run and Gun aiding in the development of CPS III. And I'm doing this video because I've been getting a lot of questions from a lot of viewers, even Patreon members, why this all ties together, and I totally get it in concept. How could a Konami core end up helping something like Capcom CPS III if it doesn't really share any hardware in common? And that's because it shares the way it does things in common, and that's going to definitely improve the odds of Capcom CPS III working on MiSTer FPGA. And this game, again, Run and Gun, a ton of fun. It'll be awesome to get a core for this and Golfing Greats. Never going to be as good as Neo Turf Masters, but it gets maybe 70% of the way. And when you're talking about a legendarily good game like Neo Turf Masters, that's pretty damn impressive in and of itself. So this is how we get to Capcom CPS III as an FPGA core, and even though I personally would pick IGS PGM as the core of choice for the next arcade core, I totally get get that I'm probably in the minority on that one. So hopefully in the next month or so we'll see some more movement on Golfing Greats and Run and Gun, and that will lead into Capcom CPS III, because again, if we were testing a beta core by Christmas, that would be awesome. But if you have any questions or need any clarifications, leave me a comment down below. I totally get we're getting into some more technical territory here with schematics, pinouts, interrupts, and frame buffers. So if you need more of an explanation, let me know. But we're done. Hopefully CPS 3 is coming soon, and I'll see you guys next time. Hope you enjoyed the video. Bye-bye.